Hi, fifth graders. We are going on to lesson 2 today, page 557 in chapter 8. We're still working in volume 2. Today we're talking about greatest common factor. So factors shared by 2 or more numbers are called common factors. The greatest of the common factors of 2 or more numbers is the greatest common factor, or the GCF of the numbers. All right, so that might seem a little bit wordy to you. Let me show you what that means. So in example 1, read along with me. How do I say that? Seaverville? I guess Seaverville. Seaverville Middle School arranges their sports trophies in rows in a display case. There is an equal number of trophies in each row. Each row has only one kind of trophy. What is the greatest possible number of trophies in each row? Okay, so here's a nice little visual for us that makes sense of this word problem. So volleyball, there are 40, football, there are 24, and baseball, there are 32. Okay, so we're going to write the prime factorization to find common factors. Okay, so in order to factor things, you have to really know your math facts, right? So this is very telling, parents, if they are wondering if they're getting stuck and this is very hard. If factorization is very hard for you, you probably need to have some more practice. And don't beat yourself up. We all, have to use these things. Practice your math facts over and over and over. It's so important. Okay, but some of them are pretty simple. And usually they keep them pretty simple for these example problems. So let's jump right to it. So 4 times what is 40? Well, like I just said, okay, that's easy peasy. 4 times 10, right? All right, and then we factor that. This is called a factor tree. They're kind of fun. They're kind of like doing a puzzle. I really like them. So 4 times 10 is 40, so you could see the visual here and so on. So now I'm going to factor out 4, which is 2 times 2. Then I can factor out 10, which is 2 times 5. And I know that I'm done when I can't do any more branches. Well, I could do more branches if it was like 2 times 1 or 5 times 1, right? So prime factorization here. 2 times 2 times 2 times 5. Okay, that's an example of prime factorization. Okay, let's do another one. 24, 4 times what equals 24? Well, 4 times 6 equals 24. Okay. And then I'm going to factor out those numbers. 2 times 2 equals 4. And then they were nice and gave us this one, 2 times 3. So again, this is an example of prime factorization. Let's do one with a bigger tree. 32. 4 times what is 32? I'm going to be so nice. I'm going to tell you 4 times 8 is 32. I'm going to factor out 4. 2 times 2. Factor out 8. 8. Let's see. Well, 2. 2 times what, boys and girls, is 8. You're so right if you put 4. Okay, and now I'm going to factor it out again. So 2, I'm going to just drop that 2 down. Okay, and 4 is going to be factored out 2 times 2. So prime factorization, 2 times 2 times 2 times 2 times 2. Cool. Okay, so now that we found the prime factors of all of these numbers, see 40, 24, 32. So we found 40 volleyballs, 24 footballs, 32 baseballs. Okay, so the common prime factors are 2, 2, and 2. Okay, so multiply to find the greatest common factor. Okay, so 2 times 2 times 2, or we could say 8. So the greatest number of trophies that could be placed in each row is 8. Woohoo! We should earn a trophy for figuring out this problem. Awesome. Good job, guys. Let's turn the page. Hopefully with these example problems, the goal is if you at least have the example problems done correctly and having some help walking through, at least when you get to like the guided practice and the independent practice, you can be a little bit more confident that you're doing it correctly. So that is my hope. And of course, please ask questions if this doesn't make sense to you. It's, it's interesting doing math, helping. These math videos definitely help, but at the same time, I don't want it to replace any help that we, could give you at our appointment time or in the classroom. Okay, so example 2. Find the greatest common factor of 60 and 54. All right, so what does that process look like? So make an organized list of all the factors for each number and then circle the common factors. Oh my goodness, how nice. They did it for you. So 60, what are all of the numbers that go into 60 with multiplication, right? And then what are all of the numbers that go into 54 that with multiplication? How nice. They did this for you. Awesome. So we are finding the numbers that they have in common. So we're going to circle. 1 is in common. 2 is in common. 3 is in common. Oh, that one's not. Okay. Oh, wait. I can't circle it up and down, but look, 6 and 6 is in common. Okay. And then nothing else is in common. So the common factors of 60 and 54 is 1, 2, 3, and 6. Okay, so if you were doing this on your own, like just say you had this question come up in your independent practice, because it might, you will just make a list like this. Okay, you will make a list, and then you will do the exact same thing. So the greatest common factor, or GCF, of 60 and 54 is 6. You're not multiplying anything here. You're just finding the greatest common factor. Awesome. So in guided practice here, you are going to find, it's exactly what I just said. You are going to find the greatest common factor of each set of numbers. So I'm not going to do that list for you, but you are going to make a list that looks just like this. Of course, it's going to be different numbers, right? Because they're different. And you're going to decide what the common factors are. Okay, you're going to do it again for number 2 with 3, 12, and 18. Oh, and this one you're going to practice comparing 3 different ones. And you're going to do the same over here. Remember, they're not giving you the lines here, but you're just making a list, 24 and 60, 12 and 18. Okay, so you're going to, because this is done for you right here, it's the perfect example for this, okay? Awesome. And you're going to turn the page, you're going to do to number 13 on the back. Okay, you don't need to do hot problem or my homework unless your teacher has asked you. And if you have any questions, as always, please let me know.